Alright, hey everybody, we're going to finish the quiz overview, starting at question 8, because question 7 ended with the last one. So, question 8 is not too involved. It's a cat running down, you can read it, but we have a hallway that's 30 feet long and an average speed of 6 meters per second. I see feet, I see meters. Once again, that's no good, so I have to convert. Convert feet to meters doesn't really matter. Oh, hold on, that messed up. 30 feet to meters. So I know that in 1 meter, I get rid of feet, there are 3.28 feet. Your conversion sheet might say 3.29. I'm not sure. I'm doing this from memory. So 3.28 feet. Feet cancel. So 30 meters to 3.28 feet. 30 divided by 3.28 is 9.14 meters. So our distance is 9.14 meters. We have a speed of 6 meters per second, and we're looking for time. I remember that my circle is DST. I'm looking for time, so I cover it up, and it's going to be D divided by S. So it's my distance divided by my speed, so 9.14 divided by 6, and 9.14 divided by 6 is 1.52, and the units are going to be seconds. And just to show you, I had meters divided by meters per second. So to get rid of the second way on the bottom, I want to multiply top and bottom by seconds. Seconds cancel. So I have meters seconds divided by meters. Meters cancel, and I'm left with just seconds up top. So 1.52 seconds. Looks like another 5. So 1.52 seconds is my time. Perfect. All right, moving on. In the conversion, this was originally a Word document. I guess this got messed up a little bit. It's a distance time graph. Distance in meters and time in seconds. Don't know why that messed up. What these numbers represent is just the y-coordinate, so the distance, and each one is every 2 seconds, it's looking like. And I'm getting that just from, that's the 5, halfway, there's the 10, there's the 15, that doesn't have one. So I'm just sort of looking and seeing that I have 1 point every 2 seconds. So, I'm going to break this into sections. This first section, before I get any kinks in the graph, so right here, section 1, then I've got section 2, a short section 3, and then section 4. So over section 1, I go from 12 down to 0. So my total distance is the distance of each of the sections, D1 plus D2 plus D3 plus D4. D1, my distance is 12, plus D2, I go from 0 to negative 10. That's what this is saying, even though it's a little skewed. So that's a distance of 10. Plus from section 3, I'm not moving, so that's 0. Plus from section 4, I go from negative 10 up to 11. So I can just do that. It's negative 10 plus whatever my distance is equals 11. Kind of just setting up an equation. Add 10 to both sides. My distance for 4 is 21. So just thinking about exactly what I need to do, what to subtract, what to add. And my total distance, this is in meters. Reminder. In meters. So I have 10 plus 12, which is 22. plus 0, still 22, plus 21 is going to be 43 meters. So my overall distance is 43 meters. If positive distance represents west, so positive distance is west, so up is west, what is the overall displacement? So now it's essentially the same thing, I just gotta look at the displacements for each section. Displacement 1 plus displacement 2 plus dot dot dot, etc. up to displacement 4. So I'm starting up top, heading down. So my first displacement is going to be a negative 12 plus a negative 10, because for section 2 I'm still heading down, plus 0 plus positive 21, because I'm heading back up. In this case, negative 12 plus negative 10 is negative 22, plus 21 gives me a negative 1 result, negative 1 meter. But I can be a little bit more specific because I have that positive is west. I have that positive is west. So negative would be negative west. Another way to write negative west is east. So really, I could say that this is 1 meter east. My displacement is 1 meter east. Another way to look, I went from 12 as my start to 11. So I had to go down 1. Up is west, so down has to be east. So there's my 1 meter east. This was, again, the analytical. This way is the graphical. Alright? What is the overall speed during the entire trip in meters per second and feet per year? So I'm going to have to do a conversion. So let me get a little bit more room here. Overall speed during the entire trip. So I know I'm blocking out the graph, but from the first one, from number 9, we saw that the distance overall was 43 meters. And the time, when I scroll, I'm sorry that the distance stays, the time was 20 seconds. So my overall time is 20 seconds. So my speed, distance over time, is 43 divided by 20, which is 2.15 seconds. Or sorry, 2.15 meters per second. I realized that I gave the wrong unit because I said we're asking for speed, and I originally said seconds, and obviously that is a unit of time, not a unit of speed, so just thinking about my own thinking, I realized I made a mistake and corrected it, which is awesome. It's also asking for feet per year, so I have to convert. 2.15 meters per second to feet per year. I know from a previous problem that 1 meter, meters on top, meters on bottom, 3.28 feet. So meters cancels, I'm at feet per second. I don't know how many seconds are in a year, but I know that in 1 hour, I need seconds here. Seconds cancel. There are 3,600. Let me write it up here. 3,600 seconds. And then that's hours. So I still got to go to years. I know that there are 24 hours in a day and 365 days in a year. So looks like it's going to be a pretty big number because I'm multiplying all my big numbers are on top. I have just ones on the bottom. Hours canceled with hours, days canceled with days, so I'm left with just seconds canceled with seconds. I'm left with just feet per year. So I got to do 2.15 times 3.28 times 3,600 times 24 times 365. Huge number. It is, I'm going to get rid of this for a second. It is, let's see, 222,391,872 feet per year. If I were being very cautious with my sig figs, my speed had originally 3 sig figs. It probably should have only had 1 because it was distance divided by time with that. But what I like to do is round to 2 digits after the decimal, so that's going to be 2.22 in scientific notation times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th feet per year. And that's my final answer. So I have 2.15 meters per second and 2.22 times 10 to the 8th feet per year. And now we got to go to the last one. What is the overall velocity during the trip? Oh, it's not the last one. The last one with actual calculations, I guess I should put. Overall velocity during the trip. Well, I remember that my displacement was 1 meter to the east divided by my time, which was 20 seconds. So my velocity is 1 over 20, which is, in decimal form, 0.05. 0.05 meters per second east. And then I need to convert, so that's my first one, I need to convert to yards per hour. So I've got 0.05 meters per second. Got to change it to yards per hour. Do not have the conversion factor from meters to yards memorized, and nor do I have the conversion sheet in front of me. So what I'm going to do is, first of all, seconds. There's 3,600 seconds in an hour. And since I don't know the direct conversion, I know that I can go from meters to something, and then that something to yards. So the connection for me is feet. I know that in 1 meter there is 3.28 feet. So seconds cancel seconds, meters cancel meters. I'm at feet per hour. I need yards per hour, and I know that there are 3 feet per 1 yard. So feet cancels with feet, and I'm at yards, should be yard, per hour, which is exactly what I want. So I multiply 0.05 times 3,600 times 3.28 on top, 590.4 yards, divided by 3 hours. So divide by 3, and again, you don't have to show this step right here. That's an equals, and I get 196.8 yards per hour. Perfect, those are my 2 answers. And the last one, I'm hoping the last one, there are 4 clear segments in the graph. Identify the range of time for each and the average speed for each segment. Alright, so I'm going to go up to the graph to do this problem, just so it's a little easier. I have to find the average speed for the 4 segments that we showed, and also the average, the average speed. So each speed is based on the distance and the time. I know that right here, segment 3, my speed is 0. Clear as day, it's not moving. I can think about thinking and not even have to worry about that one. I got segment 1, segment 2, and segment 4 that I have to figure out a little bit more carefully. Alright, so where's this time ending? I know that it's every 2 seconds. I figured that out earlier. So this is going to be a time of 8 seconds. So whatever it is divided by 8. For segment 2, I go 8, 10, 12. So the actual time of this segment is 4 seconds. And then segment 3, I'm done. Segment 4, I went from 14 to 20. So my time, 14 to 20, is going to be 6 seconds. Now it's just the distances. I have, and I know I'm going a little fast, but I have for segment 1, that distance, I went from 12 to 0. So my distance is 12. My segment 2, I went from 0 to negative 10, so my distance is 10. I don't have to worry about the positives or negatives. And distance 4, talked about it earlier, was 21. So 12 meters per 8 seconds, that looks like 1.5 meters per second. 10 over 4 equals also 1.5. No, that can't be right. 12 over 8 is not 1.5. 12 over 8. 10 over 4. 2.5. That's where I made a mistake. 2.5 meters per second, and